The AI infrastructure supercycle is no longer a speculative bet. It is a physical reality measured in megawatts and microns. Today, 5 companies have formed an impenetrable moat around the data center, controlling the thermal and power delivery architectures that make the Blackwell generation possible. Nvidia dominates the orchestration of this stack, shifting from a chip designer to a full system architect. The NVL72 rack represents the apex of this evolution, concentrating 72 GPUs into a single liquid-cooled domain that pulls over 100 kilowatts of power. To sustain this density, Nvidia has pioneered the NVLink switch system, a high-bandwidth interconnect fabric that allows all 72 GPUs to function as a single, massive compute engine. This eliminates the traditional bottleneck of leaf-and-spine networking at the rack level. The core of this system is the Blackwell GPU itself, featuring 208 billion transistors. This silicon behemoth requires a dual-die architecture connected by a 10 terabyte per second chip-to-chip link, ensuring that data movement within the processor never stalls. Powering such a massive array requires a transition to 48-volt power delivery systems. By increasing the voltage, Nvidia reduces resistive losses throughout the rack, a critical requirement when dealing with the thousands of amperes needed for modern inference workloads. But the silicon is only as fast as its memory access. This brings us to the second pillar, TSMC. As the sole foundry capable of executing the CoWoS packaging process at scale, TSMC acts as the ultimate gatekeeper of AI supply. TSMC's chip-on-wafer-on-substrate technology is the only method currently viable for bonding HBM3E memory to the Blackwell logic die. Without this precise vertical integration, the massive teraflops promised by modern accelerators would remain trapped behind a memory wall. The complexity of this process has forced TSMC to double its packaging capacity every 6 months, yet the backlog remains substantial. Their dominance in 3D fabric ensures that any competitor to Nvidia must still pass through TSMC's cleanrooms. TSMC is now moving toward the A process node, integrating backside power delivery to further improve efficiency. This innovation allows for more direct electrical paths to the transistors, reducing noise and heat at the nanometer scale. The fabrication of these chips involves extreme ultraviolet lithography, a process so delicate that a single speck of dust can ruin a multi-thousand-dollar wafer. TSMC's operational excellence in maintaining these environments is what sustains the global AI roadmap. While Nvidia and TSMC handle the compute, Broadcom manages the massive data flow between these racks. Broadcom's custom silicon and Tomahawk series switches provide the spine of the modern AI data center, enabling lossless communication at 800 gigabit speeds. Broadcom's leadership in optical interconnects and PCI Express switches makes them indispensable to hyperscalers. They are the invisible glue that binds thousands of accelerators into a coherent cluster, ensuring that latency does not erode the value of the compute investment. Their custom ASIC business is also booming, as companies like Google and Meta seek to build their own AI accelerators. Broadcom provides the proven IP blocks and SerDes technology required to bring these custom chips to life at scale. The transition to co-packaged optics is Broadcom's next frontier. By bringing the optical interface directly onto the chip package, they can reduce power consumption by up to 30%, a vital gain in the race for energy-efficient data centers. But as power draws climb, the thermal limit becomes the hard ceiling of performance. This is where Vertiv enters the equation. Vertiv is the global leader in liquid cooling and power distribution, providing the manifolds and heat exchangers required to keep 120 kilowatt racks from melting. Vertiv's direct-to-chip cooling solutions use dielectric fluids and cold plates that sit millimeters away from the GPU die. By replacing air cooling with liquid-to-liquid loops, Vertiv allows hyperscalers to pack 3 times more compute into the same data center footprint. Their busway systems and power protection hardware are equally critical. In an AI data center, even a millisecond of power instability can crash a weeks-long training run, making Vertiv's uninterruptible power supplies the ultimate insurance policy for AI safety. Vertiv's service network also provides a massive moat. Maintaining high-pressure liquid loops requires specialized engineering expertise that generic HVAC firms simply do not possess, locking hyperscalers into long-term service contracts. Finally, Supermicro acts as the rapid response system integrator. Their building block architecture allows them to be the first to market with fully integrated Blackwell clusters, delivering air-cooled and liquid-cooled solutions faster than traditional OEMs. Supermicro's manufacturing scale in San Jose and Taiwan allows for massive rack-scale deployments, where entire clusters are pre-tested and shipped ready for power-on. Their tight partnership with Nvidia ensures they are often the primary vessel for the latest silicon reveals. They have optimized the total rack solution, integrating storage, networking, and compute into a single, cohesive unit. This approach reduces the complexity for customers like Tesla or xAI, who need to deploy tens of thousands of GPUs in record time. By offering liquid-cooled racks at scale, Supermicro is helping data center operators reduce their power usage effectiveness, or PUE, a metric that has become a critical KPI for the industry as energy costs soar. The convergence of these five giants has created a new industrial base. Nvidia provides the brain, TSMC the body, Broadcom the nervous system, Vertiv the life support, and Supermicro the protective armor. Together, they are the architects of the intelligence age. As we look toward 2026, the focus will shift from simple compute capacity to total system efficiency. The winners will not just be those who make the fastest chips, but those who can manage the staggering physical demands of the AI infrastructure supercycle. This concludes our deep dive into the 5 stocks dominating the data center war. In a world of digital intelligence, the ultimate advantage remains physical.